Whatever.
When you're done with it, what do you do? Discard?
Oh, you guys, I handed out the 1-7 notes yesterday, I believe. Is that right? Right? So if you were here yesterday, I gave you the notes that I'm gonna go over. So can you guys look in your stuff and see if you have 1-7, and then put your MacBooks away, please.
We have a starter.
Did I hand out 1-7? Yeah, you did. We don't have a startup.
Okay.
Extra piece of 127.
Hey, you want this?
Woo!
I get it, Riley.
Pass it, Landon.
Carson, do you still plan to come in the morning? Did I tell you it was 7:30?
Sweet.
Yeah, I get here at 7:30. Sometimes a little earlier. Okay, no more throwing.
Sorry, I said
Okay, listen up.
You said he can stay there. If he's sleeping, he can stay in, right?
All right. So today what we're gonna do is we are going to learn how to do rotations, reflections, and then actually we're gonna talk about rotations, reflections, and translations, but we're gonna actually do reflections and translations. You guys got a cheat sheet for this chapter like yesterday or the day before. Can you take that out, please? Because we're gonna write some things on that, okay? Yeah, he does. It's like the one that has like triangle, quadrilateral. Do you guys know what I'm talking about?
Yeah.
The cheat sheet.
Maybe.
Oh, I don't want that.
Look, I got you some notes on it. Are we good? Okay. So we're gonna start off, you guys, down here. And as I said, we're gonna talk about, it looks like this, you guys. And one side looks like this. Okay. All right. So when you guys learned about reflections early on in math classes, you probably talked about flips at first, where you take something and flip it over. And today what we're going to talk about is doing reflections over the X and Y axis. Do you guys all know, I think you do, that this is your X-axis and that's your Y-axis, right? Everybody knows that? So sometimes today we're going to reflect things over the X-axis, and sometimes we're going to reflect things over the Y-axis, okay? Another thing we're going to do today is called a translation. And a translation is taking a figure, you don't turn it at all, and you don't flip it at all. You just slide it. So you can slide it left or right, you can slide it up or down, and you can slide it diagonally, okay? The last thing we're gonna do today is talk about a rotation, and we kind of cheat. Rotations can be any degrees around any point, but when we do them, we always do 180-degree rotations about the origin, okay? That is because doing that kind has a rule, and you don't have to use a compass and a protractor, okay? Now, if you guys go to this page right here, all we have to do on this is say whether it's a translation, rotation, or reflection. What do you guys think this one is?
Rotation.
Rotation, very good. Okay, then if I go down to B, what do you guys think that one is? Yeah, it's reflected. Can you tell which axis it's reflected over? The Y. You don't have to say that, but just so you're aware of that. Then, what do you guys think of C? C is the one where it slides and it's called a translation. Okay? So when you just take something and you slide it, you don't flip it, you don't turn it, that is called a translation. Okay? This is a reflection over what? The x-axis. Very good. Okay. Then if I look at E, what do you guys think on that?
Rotation.
Rotation. Yeah. And then, how about this one?
Translation.
Yeah, this one is just kind of slid over. And anytime something is not turned or flipped, that is a translation. Okay? D was a reflection. Did everybody get all those? Okay. Now let's go here. We just have a couple more just like this, where you're taking a figure. So what's happening in this one is this, whoops, I should use a different color. This is being moved to here. And when, I'll just give you a hint, this is a rotation. When you have a rotation, it's always reflected about a point and a certain amount of degrees. So this one is a rotation. What about a van sliding door? Translation, very good. It's just kind of sliding it. We're gonna actually do some too. So, what do you guys think about footprints? Reflection, very good. All right. Now, here's what I would like you guys to do, and I strongly suggest you guys have your cheat sheet out, and somewhere on that cheat sheet, and you don't want to write super big, we're gonna write this, and then I'm gonna put a little note down here, okay? Change the sign of Y coordinate. And so somewhere on your sheet write this, okay? And then we're also gonna do this, and I'm gonna put a note for this one. seat up so you aren't so comfy.
Well, it's just about me.
I don't think that's comfortable.
Switch.
Well, he's
Can't, you know.
probably making it easier to fall asleep leaning back.
I mean, it is school. It's pretty easy to fall asleep.
I mean, yeah, it is pretty boring here. No, like in the
Not your
school,
classes, all of our classes.
Just all classes, except with Ted.
Okay, are we good? Did I give you enough time? So I'll show you what I mean by this. And if you wanted to show an example, you guys could on your notes, okay? So here's what I mean. If they gave you the point 2, 3 and asked you to reflect it over the x-axis, what this tells you to do is change the sign of your y. You change the sign of the other coordinate. So if it's over the x, we change our y. So what I mean by that is your new point would be 2, -3. Notice I keep my x the same, but I change the sign of my y, okay? If I look at what happens if I reflect it over the y-axis and I took the point 2, 3, okay? This time I changed the sign of my x coordinate. So what do you guys think this would be?
-2, 3.
Very good. -2, 3. Just the x changes sign. So you always change the one that's the opposite. If you're going over the if you're going over the y, you change your x. If you're going over the x, you change your y. Is that pretty easy? Okay. All right. So now let's try one of these. So you guys should all have this on your sheet. So what you're gonna do on these is you're gonna first graph the original figure, and then you have to graph your new figure. So here's where we're gonna start. We're gonna graph these 3 points on here. So A is over 3 up 2. We're gonna put a dot and we're gonna call it A. B is over 2 down 2. We're gonna put a dot and we're gonna call it B. C is over 4, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5, and that we call C. And what we're gonna do is connect those dots like this into a triangle. Okay? Now, what's gonna happen, you guys, is we are going to reflect this figure over the x-axis. Does it make sense to you guys if A is above the x and I reflect it over it? Wouldn't A end up down here? Do you get that? And if B and C are below it and I reflect it, those are gonna end up here. So I'm gonna show you 2 ways to do this, and then you guys decide which way to do it. Okay, so here's the first way. If you don't wanna use the rule that I just had you guys copy down, what you do is you start at A. We're going over the x, so you count straight down to your x, 1, 2. And if you count 2 down, then you would go 2 in the opposite direction, and that would be your new A. And this is kind of weird, but when you draw your new A, you put an asterisk by it, and that is called A prime, and that's just how they label your new A. Okay? So I was 2 above the x, so I went 2 below, and then I put my new A. Now, B, if I count straight up, is 2 below. So would you guys get that you'd go 2 above, and that would be your new B? Everybody understand that? Okay. And C, if I count straight up to my x, it's 1, 2, 3, 4, 5. So then I'd go 5 in the opposite direction, 1, 2, 3, 4, 5. And that is my new C, and I put an asterisk with it. And then what I do is I connect those, and that's what it should look like. And what you would ask yourself then is like, if you folded this right here, would your C's match up? Would your B's match up? Would your A's match up? And they would. So that is one way to do it. The second way you guys could do this is you could use the rule that I gave you and you just copied down. Do you guys remember, if you go over the X, which one do you change? The Y. So your 3 would stay the same, but your 2 would be -2. And then you would come over here and you'd plot that over 3 down 2, and notice that's the point we got. Okay? Then if I did my B prime, okay, what do you guys think your new B prime would be? Yep, the 2 stays the same. This changes sign, so it's 2, 2. And if I look over 2 up 2, that is where I put my B prime. And then for C prime, okay, my 4 is gonna stay the same, right? And what is the Y gonna be? +5. And if you look over 4 up 5, that is our new C. Okay? Does that make sense? So now we're gonna go down and we're gonna do the same triangle, but this time we're gonna go over the Y axis. So let's first just graph the triangle. So A is over 3 up 2, and you're gonna put an A. B is over 2 down 2, and we're gonna put a B. C is over 4 down 1, 2, 3, 4, 5, and that is our C. And then we're gonna connect those. Okay, now again, 2 different ways to do this problem. The first way, if you want to do the counting way, this time we're going over our Y. So I would start at one of my points and I would count straight over to my Y. And for A, it's 1, 2, 3 away. So I'd go 1, 2, 3 in the opposite direction, and that would be my A prime. For B, I'm 2 away, so I'd go 2 in the opposite direction, and that is my B prime. And then for C, I would count, and it's 1, 2, 3, 4 over, so I'd go 1, 2, 3, 4, and that is my C prime. So that is the way to do it if you're counting on the graph. If you do it the opposite way, which, not the opposite, but the way I had you do the rule, your A prime, if you are going over the Y, which coordinate are you gonna change the sign on? The X. So it'd be -3, 2. Your B prime, what do you think that one should be? Yep, -2, -2. And your C prime should be, very good. Okay, now I'm gonna have you write one more thing down on your cheat sheet, which is this. So I'll give you a second to copy that. Okay? And then we're gonna do 2 translations and then you'll be done for the day. Did I give you enough time? Okay, so first of all, when you have a translation, it's gonna look like this, you guys. It's gonna have these arrows on each side. It's called a vector. Don't worry too much about that. It's no different than if this was in parentheses, okay? But here's what happens. This first number tells you how much to move each point on your graph, left or right. And the rules are just like plotting a point. So do you guys know if you were plotting 2, -5, wouldn't we go right 2, down 5? Do you guys get that? So what happens with a translation, if it's 2, -5, if this is your diagram and the vector that you have to translate is +2, -5, for each point, you'd go over 2, down 5. Okay, and that would be where this new point goes. Okay, then you would go, say this is your B. Same thing, you'd go over 2 and then down 1, 2, 3, 4, 5, and that would be where your new B prime goes. And then if this was C, same thing, over 2, down 1, 2, 3, 4, 5. And then that would be your C prime, and this is your new figure. And it was slid over 2, down 5. So let's go, and we're gonna do this last page here today. We're gonna stop after this, and we're gonna do this. So first, we're gonna graph the original figure by graphing these points. So I'm gonna go to my graph. Q is -7, -2. So I would go over to -7, down 2, and that is my Q. Okay. R is -8, -5. 1, 2, 3, 4, 5. That is my R. S is -4, -7. And that is down here. That is my S. T is -4, down 2. That is my T. So I would connect these, and that would be my original figure. Okay? Now, what you do is they're gonna give you a vector. And this time they give us 7, 1. Do you guys get if you were plotting 7, 1, wouldn't we go over 7, up 1? Do you guys get that? Right 7, up 1. So what we do in this case is for every point on our graph, we count over 7, up 1. So if I do that, say I'm moving my T, I go over 7, 1, 2, 3, 4, 5, 6, 7, up 1, and that is my new T, so I call it T prime. Then for my Q, I go over 1, 2, 3, 4, 5, 6, 7, go up 1, that is my Q prime. For R, over 1, 2, 3, 4, 5, 6, 7, up 1, that is my R prime. And for S, 1, 2, 3, 4, 5, 6, 7, up 1, that is my S prime. And then I connect my dots. If you did this correct, for all of these should look the same size, same shape. Yeah. So basically we moved it over 7 and up 1. Okay. We're gonna do one more and then I'll be quiet. So let's plot these 3 points on our graph. So I'm gonna go left 2, up 3, and that is my M. Then I'm gonna go left 4, up 6, that is my N. And then I'm gonna go left 1, up 8, That is my P. So here's what the original figure looks like. Okay. Now, if you guys look at what our vector is, it's 2, -3. Now, if you were plotting that on a graph, do you guys get you'd go 2 to the right, down 3? Okay? So for every point that's here, you're gonna go over 2, down 3, and put your new point. Then you're gonna go over 2, down 3, your new point is right here. You're gonna go over 2, down 3, your new point is right here. And that is your new figure. Now, here is your assignment. I thought I put it on here, maybe not. Okay, so here's what we're gonna do instead, because it's not on here. Let's go to Schoology, and I put it on there, I believe. Okay, so you guys can copy this off of Schoology. It's probably easier to see, but I need to explain this to you. This right here is your assignment, okay? This tells you which 6 of them go on graph paper. So these are not additional problems. They are just problems that need to be graphed. Do you guys get that? Okay, so these are the problems you're gonna do, and everyone needs graph paper. You do 6.
Come on, Calvin, after. Yeah, congratulations.
Wait, is it in Schoology?
Yeah. I'll be right back. How long?
You're hurt? You're hurt?
One more. Oh, that's okay. Do you want to just do on the right next to it? Did you guys think it was hard today?
No.
So tomorrow we're gonna finish this. You could write everything on this sheet and just turn this in if you wanted to.